we talk about scaling analytics, there are kind of two areas that this falls into: scaling up and scaling out. In big data, we talk about the 5 V's of big data, and I've aligned in this case the scaling of analytics to the same 5 V's. So in scaling up, we have a larger volume of existing data, so increasing the amount of information coming in from sources you already have. We've got an extended variety of sources, so John spoke to this a little bit in what types of information are you bringing into your systems and then using. A higher velocity of ingestion, so moving towards real-time and stream processing. Those are all parts of a scale up. On the scaling out side, you can pull all of this information together, but you still have to ensure veracity of the information provided. That means governing it. That means ensuring that other areas of the organization trust the data that you're putting together and eventually the analyses that you're putting together, which also brings value to those other areas. So while we may have started this as a churn model coming out of the marketing group, there are other areas that benefit from that. And so that's really a scale out approach. So let's talk about where we start. Typically, when you have, in your organization, you'll typically start with a structured data set in your data ecosystem, but that's going to change over time. You may have data warehouses or databases that are part of your structured data environment. It could be ODS. These typically come from constituent data environments from various parts of the organization and may or may not be stitched together. But then there's semi-structured data coming from other sources, things like web tracking or product attributes, connections between similar entities in a graph style. All of those end up being in a separate environment. They can't be modeled readily into a structured environment, or it requires a heavy lift. Then there's all the unstructured data, so things like emails or documents, images, videos, audio files, all of which provide valuable content that could be mined, but require additional sources and additional storage. And then as we move towards real time, increasing that velocity towards streaming data, where you might have IoT or sensor information, social media, weather, traffic, stock quotes, all kinds of different real-time information that could be fed into applications. It starts to increase that velocity, and now we have point solutions for all of these things. But there is another option, which is to scale using something that can actually pull all of those together. And so that little icon down at the bottom is Azure Data Lake Storage, which can actually pull all of these things together so you can analyze them in one place. Now that data lake allows for a multitude of data sources and data types to be pulled together in a no schema required method. So we talk about it as being schema on read, so you don't have the same typical ETL lift that would otherwise make a process like integrating your data in this manner much more arduous. There are also tools that sit on top of Azure Data Lake Storage, such as Data Lake Analytics and Azure Machine Learning, that allow it to be used in your modeling and data science much more readily. You can also use HD Insights, which brings in Hadoop and Spark, as well as other technologies to do stream processing against what's stored. And it's not to say that it has to sit in your data lake. So obviously there are some technologies that are easier to use or that are more readily used, like SQL or more structured environments. Once everything is stored in your data lake, it becomes a component to be read into a data warehouse. So it's in talking about the Azure SQL Data Warehouse, that enables you to bring in data from that data lake, from all of those unstructured, semi-structured stream processing sources, and leverage them against other structured data, such as SQL databases or other environments. You can have them in Azure or not. All of those are then pulled together into a data warehouse if you want it to be structured. And those can then be served up to applications like Power BI for business intelligence, or into machine learning applications much more readily, so that you're not dealing with the same schema on read as you move up the stack. The nice part about Azure SQL Data Warehouse is that it's immediately massively parallel processing, which gives you the same scalability and parallelization for the volume processing that you would otherwise get with a massively parallel processing appliance without the enormous overhead. So you don't have to buy a multi-million-dollar box to get those same benefits. Let's talk a little bit then about scaling up our churn model. How does this apply? Well, in our churn model, what you can see here is the actual weightings. So this is a feature of using Azure Machine Learning. You can go in and see your model, how it's been trained. In our actual weightings, we have a number of different features that could be leveraged on a larger scale, so scaled up. First of all, we used an extract. In the first webinar, we had an extract of several thousand records, and we used a small set of data features. In this case, we're going to talk about how we can scale those up, and there are a few in here that we'll kind of call out. We have contract data, we have charge information, we have technical support, and of course we have the size of that file. So if we think about the original scale, we had an extract, which we would move towards being the full database. We would score the entire customer file. We had contract type in there a couple of times, one for a 2-year contract, one for a month-to-month. What we would look for there is a velocity change, so that if someone changed their contract, it would trigger an update to their score. So we can immediately reflect that information. We also had total charges. So think about what would happen if you're able to identify abnormal charges above a contract. This was for telecommunications, so that might mean something like going over usage or having international calls in a given month. This would enable you to update the score to reflect those changes and to potentially trigger some business processes around that. We'll talk about that in just a moment. We also had technical support usage, which was a binary. However, if we were pulling in IoT data, such as sensors, we could actually flag outages in real time to anticipate the need for technical support, which gives not only a velocity increase towards real time, but also volume as we're pulling in more and more of this IoT data. There were also types of information that had been missing from our churn model, simply was not there. There was no sentiment data. There was no information about how a customer service call had gone or a technical support service had gone. So imagine, if you will, if you had social media mentions and sentiment. This could all be fed from both internal systems like a live chat or a customer service application that's reading and interpreting the information coming from those calls, converting audio into text and sentiment, or from social media that's being pulled in from third party. That could all provide additional scale for your telco churn model. Let's move then to scaling out. We started with this analysis as part of the marketing area, but it has applications across multiple other areas of the organization. So scaling out really means leveraging those insights, analytics, and models elsewhere in the organization. For example, how does your churn model impact hiring practices for a call center or field service? What areas of network engineering should be addressed to minimize the outages that are causing this increased churn risk? Have we properly accounted for expected customer losses in our financial projections? Is new or different equipment needed to support customers in certain areas that have frequent service problems that are leading to customer loss? These are all areas that can derive value from having the access to the churn model or other analytics, but if we stay in our silos, it will never get there. That said, we need to think about it as not only how do we use this in the area that it was first intended, but who are our constituent stakeholders? And that may be a broader audience than we initially thought. We need to evaluate who else has a need or a stake in using this information. How might it be used? Of course, they'll only use this if they trust it. So how do we scale out with integrity? You need to have a common understanding and a common pool or lake of data to achieve consistency in the definitions and usage across the organization. A data lake storage provides an environment to land all of that information without defining its structure in advance, as we talked about before. But you still need to have governance imposed to ensure that the necessary consistency is there to implement processes. That requires stewardship and governance. It gives you the opportunity to take all of that information, land it in your data lake, and then provide a common definition layer for both business users and for your analysts. Often the big data analytics and reporting teams help to define those structures and the data dictionaries that then get leveraged in other APIs and other environments. The other place where integrity tends to get lost is when you scale out your data science team. So rather than just having more access to the data, you also have multiple interpretations of how to use that data. So the data will only do what people tell it to do, which means that they should all be telling it roughly to do the same types of things. So when you get new data scientists in, and sometimes they're siloed, sometimes they live in different environments within the organization, there tends to be a proliferation of code, of tools, and of business rules that are being applied. And these data scientists and analysts are often kind of in their own corners doing their own thing, yet they really need to collaborate. It's crucial for data-driven organizations. So to do this, you have to have a shared environment with common data sources, script libraries, and definitions that promote that coordination and collaboration across data science teams. With those structures in place, they can reuse not only the data sources, but also the insights and models from one to the next. Some of the ways to do this are to use a source code repository or management system such as Git. Can provide a combined environment for storing the models and the data sources that they're using, such as Azure Drive or SharePoint, and even just providing a place where data scientists can chat with each other, like in teams, and distribute insights to other analysts throughout the organization. All right, so let's talk a little bit about scaling out our telco churn model. One of the things that Azure Machine Learning provides that we saw in both webinars 1 and 2 is that there are multiple ways to deploy a machine learning model. One is to write back to the database, as we saw in webinar 2. The other is to do a real-time web service. So just to give you a shot of that, there are multiple ways to deploy those web services as well. In a write back, you're typically using a batch mode, which is a bit slower. And then in web services, you're in a near real-time capability. So let's talk about how that might influence different areas of the organization. So remember, we started in marketing. We created a dashboard for a marketer to use, but there are other areas that this can touch. So in call center, we would potentially utilize both batch and real-time processes. What you see here is sort of a screenshot of what a call center rep might be looking at in talking with a customer. And there are a couple of ways that we can use the data from the churn model in call center. The first is to route high churn propensity calls to a dedicated retention team. So the actual representative that someone is talking to may be different based on whether or not they're likely to churn. During the call, we could actually rescore their churn using those web services based on outcomes. So as the call center representative moves through their workflow and clicks on various outcomes for the customer, it might say that this customer is less or more likely to churn. And then we would feed those updated scores back to the database for use in other applications, such as route management. This would be for a field service technician and how they prioritize whom they need to serve and repair in a given day. Again, we would use both batch and real time. For example, we could prioritize high value, high risk customers for service when doing our daily route selections, so that it would show not only in the manager, but also to the field technician themselves, whom to serve when, based on their risk. Once service is complete, you could have a real-time trigger that updates and the scores based on the time to resolve, or if there's a continued problem, to update that as well. All of that could then be fed back into finance. So imagine this would be a batch process. Imagine that finance wanted to adjust their accounts receivable based on projections for their churn. We could have a daily batch that rolls up revenue likely to churn in the next 30 days that then gets sent to a financial system where the general ledger is automatically adjusted to reflect those latest estimates. Because it's finance, of course, there's an auditing process. So at the end of the month, the audits would check movement from prior month close to current month close to see how much was adjusted. Those are just a few of the ways that one model could touch other parts of an organization using more and different types of data. I got through this faster than I thought. So the key takeaways here, scaling your customer analytics hub means fundamentally changing the definition of scaling to include not just more, but also varied data at increased speed used in more ways. Integrated solutions like Azure provide more flexibility and future-proofing than point solutions, and they include lower overhead and lower management. Technology is not the only area to address scaling in your customer analytics hubs. You have to consider the processes and the people supporting and using that technology to ensure that they're all in the loop and able to maintain the veracity of your analytics. Governance and trust in the data leads to that reusability across business units. And the activities that are associated with analytics are just a starting point. There is business transformation that spans well beyond the point of origin as we think about all of those constituents, all of those stakeholders for using that data and those analytics, and then coming up with the next analytics for the organization.